Hi guys, I hope everybody had a great weekend. So we talked about series and sequences. In section 4.2 we talked about the arithmetic sequences. So today, geometric sequences. This is going to bring us closer to, I think, my favorite part of mathematics. You know, every part of mathematics is the best for me, but still that is going to bring us to mathematical induction. That is my favorite part of mathematics. Anyway, so today we are going to talk about geometric sequences. Again, this should be somehow familiar for you. Geometric sequence, it's a sequence in which the ratio between two terms that are one after another is constant. And that is going to be called a common ratio. So if you want to figure out the common ratio, what you should do is you should take the next term and divide it by the previous term. The common practice is to check it twice. So notice I took -2, divided it by 8, and -1/4. I assume that this was the answer, but you should try one more. So if I take 1/2, and if I divide it by -2, you know that division, it is multiplication by the reciprocal. And notice how convenient, -1/4, so the common constant ratio is -1/4. So they are asking us to find the next three terms. I took 1/2, multiplied it by -1/4. I got to -1/8. Then I took the -1/8. I multiplied it by, again, -1/4. Here's my answer, and so on. Here are a few examples for you. There are some variables. This may be a little bit more difficult. I will just start for you common ratio. So you will take this guy, so the next term, 2w plus 6, and you will divide it by w plus 3. What can we do with this? Let's make those two numerator and the denominator, let's make it into something that we can simplify. So if you take 2 out, look at this, how convenient. We figured out that the common ratio is equivalent to 2. Okay, so now you will find the next one by multiplying it by 2, and so on and so on. So finish B, finish C. I did one here that is similar, and I think I thought this would be the most difficult one. So here we go. I want you to take a look at this. I took the next term, divided it by the previous term, factor -16 out, factor 64 out. Again, how convenient this factor simplifies here and here. -1/4 is going to be your constant ratio. And then I found the next two terms. So this is my next one, -r plus 2. And then next one was this one. One thing that I forgot to bring from school was my whiteout. But Easter Bunny gave me a whiteout today. And this is a true story. I can show you the picture as a proof. Maybe I'll post that as my homework, but I got a whiteout and it's right in here. Watch this. Everybody should get one like this. All right, if you go to the next page, if you look at the top of the page, there's a formula if we want to do something very similar that we did for the arithmetic sequence. We can find the nth term of the geometric sequence, and the formula is given right in here. So you will take the first term and you will multiply it by the common ratio to the power of n-1. So let's look at example number 2. We can write an explicit formula and recursive formula to find the nth term of any geometric sequence. So the explicit formula, here we go, this is our explicit formula. And we are going to take the first term, which was given. We need to figure out what is our common ratio. And again, -2 divided by 8. And again, something that I didn't do, a very common practice, 1/2 divided by -2. Just to make sure that what we are saying is a true statement. 1/2 times 1/2 negative, and that is going to give me -1/4 or -0.25. So here we go. I have, for my explicit formula, I have 8 times a -0.25 to the power of n-1. And for my recursive formula, I have a 1. So if we think about this, you will take the previous term and you are going to multiply it by -0.25. So I did not finish this one, so we can do this right now. If I want to figure out, well, the nth term, so I guess I did finish it. I found the nth term using the explicit formula, and I found the nth term using the recursive formula. Here's one for you. All right, now we did this for the arithmetic sequences. So of course we are going to do the same thing for the geometric sequences. I have a few terms that are given for me, and well, this is telling me that this is a geometric sequence. If it didn't tell you, then you would have to check, but because I know I found the common ratio, 151.2 divided by 189, use the calculator. This is quite common to use the decimals for those type of examples, so that's fine with me. Just use the calculator. Any calculator is good for this. And the question is asking us to find the 27th term. Because it is a 27th term, I am going to use the explicit formula. And the explicit formula, I just copied this down right in here. And the first term is 189. The common ratio we found 0.8. And I will raise it to the power of n-1, so 26. And again, use the graphing calculator. Here's your answer. There are different types of examples. So if you look at this one, we want to find the 12th term. If we know the third term and r. So notice that knowing this, I was able to find the first term. And now having the first term, we can find the 12th term using our formula. And just plug in the numbers and finish this one. All right, there's example number 4. So there's a lot of applications for the geometric sequence. And this one is interesting, just the way it's written. So you have somebody that purchased a car for $15,000. And at the end of each year, the value of the car depreciates 11%. You can check that, you can look that up if that's a true statement. Is this that much that depreciation of the car would be? Well, they are telling us it is for this particular problem. So my starting value is 15,000. R is 0.89, and now why is that so? So if you think about this, this is 100% of the price, and we know that depreciation is 11%, so what you have left is 89%, and 89% is 0.89. And here we go, my formula for the nth term, or in this case it would be the year, whichever year you want to find what is the price of the car, is given. So now, having said that, we are able to figure out what happened 7 years later. Plug the 7 in here. This is going to become 6. Remember, it's always 7 minus 1. It's the n-1. And the value of the car after 7 years will be $7,454. Well, don't buy a car as an investment. And here is example 5 for you. All right, now we talked about arithmetic means. So now we have the geometric means, and it works very similar. So you have a geometric means, the terms between two known non-consecutive terms of geometric sequence. So let's say we want to write a sequence that has indicated geometric means for each pair of non-consecutive terms. So we have 480, we know that that's the first term. We know that negative 7.5, that's our last term, and we know that there are two means in between. So having said that, we do know that this is our nth term. This is our first term, and we know that we have 1, 2, 3, 4 terms. So again, this number is 4 minus 1. And my only unknown for this is r, which is our common ratio, which I can find from this equation. Common ratio, if you look at my calculations, is negative 1/4. And once you figure out the negative 1/4, once you figure out your common ratio, you can figure out the second and the third term. Okay, here are two examples for you. And again, very similar like for the arithmetic sequences. For the geometric sequences, if we look at this here, we talked about when we talked about the arithmetic sequences, we figure out what the series are. So if you look at the table that I made here on the bottom, if you look at the geometric sequences, this is just listing the numbers that will follow the geometric sequence. If you now want to talk about the series, it's if you take all of those numbers and add them together. So having said that, we have two formulas that will calculate the sum of all the terms of the geometric sequence. Take a look at both of them. We have the first one that uses the first term and the r, and then we have the second one that uses the first term and the last term and also the r. So we'll see which one is easier, which one is the better ones for whatever kind of problems. All right, so let's take a look at example 7. We want to find the sum of the first 6 terms of the geometric sequence. This one is given here. Notice I do know that this is my A1. I can easily find the R, and I did the best practice ever. So I took the 14 divided by 8, but I also did 24.5 divided by 14, and I figured the common ratio is 1.75. Now, having said that, I use the first formula, and the first formula because I have the first term and I have the r, and I do know how many terms is in the series. So 8, 1 minus 1.75 to the power of 6, divided by 1 minus 1.75. Again, use a calculator for this. We would get it that our 6th term of this geometric series is 295.71. The second example uses the other formula. So notice what is given here. I have the first term. I know the nth term, and I do know the r. So I plugged in my numbers, put it into the calculator, and done. And the question here would be, well, could I use the other formula? Maybe you could figure it out, but it would be the longer way because we do not know how many terms there is in this series. All right, example number 9 is a little bit different. So it has our sigma or sum notation, and we have the geometric sequence that is given for us. So the most important thing is, given the upper bound and the lower bound, is to figure out how many terms we have. So to figure this out, you will take your upper bound, take away the lower bound, and you will always add the 1. So my n is equivalent to 6. All right, the first term is equal to 3 times, again, plug in n is equal to 2, because that's our first term, and that was 15. I did find the second term as well. And the reason why I did this was because I wanted to see what the common ratio was. And I took the 75 and divided it by 15. My common ratio is 5. However, did I have to do that? In our formula, when we were given our formula for the at the beginning of the class, or at the beginning of this paper, we did see that whatever we are raising to the power of n minus 1, that is our r. I just wanted to show you that this is a case. So this is the base of the exponential function. And now, having the r, I was able to find the sum of, in our case, 6 terms. So here we go. I just plugged in the numbers and got that the sum of all of those would be 58,590. Example 10 and example 11 is for you. And we do have the last thing. So what happens if the series is infinite? So what happens if the numbers don't have the number of terms, because they will go on forever? So like, for example, this one, 9 plus 3 plus 1 plus, and we do not have any end, we do not have any information how many terms there is. So we can still figure out how what is the sum of this series, as long as r is less than 1. I shouldn't say that. As long as absolute value of r is less than 1. What does this mean? It means that r has to be less than 1, and at the same time r has to be greater than -1. All right, so in other words, r needs to be a fraction. So if we look at this one, the first thing you need to do is you need to find the common ratio. 3 divided by 9, again, a good practice, 1 divided by 3. We see that r is 1/3, and that is going to meet our restriction. And because this is happening, plug in the first term, plug in your r, here you go. The sum of the sequence, the sum of the series is 13.5. B1 is for you. And I have the last one that I did. So notice that what happens is my n is equal to 4. This is going to infinity. And my series is described with this formula. So again, common ratio. Like I said in the other example, this is our r, and because r is 0.2, which is less than 1, there's a sum. So 4 times 0.2, 4 minus 1, and again 4, because this is the lower bound, that's my 4. So I found that the first term is 0.032. I do need the first term in order to find the sum. I plug in the first term, I plug in the r. Here is what all my terms will add up to. All the instructions, I will write it up on Teams. I hope everybody is doing well. Please come see me during the team meetings. You should see that. If not, send me a message, send me an email. I can always add you or invite you. All right. Again, just have fun with this.